Hi guys, um, anyone working on 2D materials and devices most probably has seen structures like this in either papers or in PowerPoint presentations and so on, and have wondered how to create these. So if you are a bit familiar with Blender, you know that you can import and make a lot of structures, regular structures like the cubes, cuboids, spheres, etc. But making the crystal structure of, say, a material like the molybdenum disulfide is not easy to if you want to make it scratch from Blender. So I was really confused on how to make these structures, and I had to search around a little bit how to make structure like this. So hopefully for you guys watching this would be a lot easier than it was for me. So for first you need to get the crystallographic structure of the material. So we will take MoS2 as an example here. The structure shown here is not exactly MoS2, but that will be easier. So first you Google MoS2 CIF file. This is the crystallographic information file which has information about all the crystal structure and atom positions. So I have already opened it here, and here you can see the crystal structure. You get a lot of other details too if you want, and then save the CIF file. Now you need to open this CIF file in another software known as Vesta. It is used to view crystal structures. So file, open the one you downloaded. So I have opened it again. Sorry, that is PDB. So of course, when you open, usually it doesn't open like this. Let me just, yeah. Typically it opens like this, where you have one primitive lattice is shown. So for MOS2 devices, you need a single layer of atoms with single or multi-layer as per your requirements with certain area, right? So you go to objects and boundary, and for single layer set Z to around one layer thickness. So let's set 0.5, and so let's set 5 by 5 to get around that number of angstroms there, and see you have got the crystal structure, and you can see it in different orientations here. You can see this is hexagonal and looks just like your MOS2. Well, this is exactly the MOS2 crystal structure, and you can always change it to different shapes, but ball and stick is the it looks the best. And once you have this, you go to file, you export data, select PDB option here and save as PDB. PDB stands for protein database. Okay. Once you have saved this, you can import the PDB file into Blender and take it from there. So first you go to file and import. You have protein data bank option, that is .pdb. So click that, find your PDB file. So here I have MOSSE 10 by 10 PDB. This is a variant of molybdenum disulfide. And then the type of the import you are changing into mesh. So here you have an option to change the sphere size and distance. So to make things visibility better, I would select it to 0.7. Of course, you can adjust it as per your requirements, and then click import. So you can see that the entire thing has been imported, but the problem with PDB is that it imports as a single object. So you can see you cannot select a certain section of it. So if you want to make a device out of it, so you will have to cut it. So to cut this, first you have to convert them into real object. So for that, go to select all by type mesh. So here all the mesh is selected. Now go to object and edit. Apply, make instances real. This will take some time depending on the amount of objects selected on the screen. It can take even 5 to 10 minutes, and the blender may freeze during that time. Do not worry, be patient. You can see that every object is made real now. So right now, if you click on one of them, you can select one. Now we can select and delete and reshape the matrix as we like. So right now, this is how it is. We would cut it into a square. So let me select it. Okay, it is not selecting that much area, but see now this much area is selected, and there are some unwanted elements that is getting selected there. uh, that's okay, and press delete. Again, this also will take some time. So after editing, we have a square piece of our MOS2 here. Let me just move it around so you can see that it is good. And if you move to rendering more, it looks like this. Cool, right? So now we can do certain things. First, select all. See, you can see that everything is selected. Select none. Select all by type mesh and object shade smooth. So with this, you can see that the atoms are actually smoother. So that looks good on our devices. So to the next part, actually, uh, now you have two options to go. You can either select everything, click A, and join. In this case, this entire object becomes single. That would make it easier for you to handle each of them. But let's. So we have a structure ready, and next would be selecting everything and joining. Add mesh cube to create the substrate. So I have made the substrate and the dielectric already. So let me change it to shaded view. What is that view? Yeah, viewport view shading. So you can see I have substrate as well as dielectric already made as cube meshes, and again source and drain contacts too. So how the device. So this is a simple backgated FET uh, using MoS2, and you can, of course, this is not MoS2 because you can see these two are different colors. So that's a different exercise, but of course you can always put any 2D materials here, and you are done. And of course, just choose the best angle for you to see, and go to view, align active camera to view, so you get it, and render image. This is the rendering of our 2D FET. Hope you all like the video. Thank you.